See? Yeah, thank you, Ben. So this is my component which I used it, right? So I'm going to file equipment electrical harness assembly, and I'm going to insert my existing component. So now I'm going to use this data, this one and this one, bringing these two components. You can just see that I'm going to have my component, snap the entire component and move it as per the requirement. I'm just moving this, right? And I'm going to first represent it and convert it to design mode so that I'm okay, fine. So in this case, the first step for me is that I would like to create first GBN. This is what we discussed last class also, that this is the first step which we are going to create, GBN. So this is the first step. So until unless you are not converting your product into GBN, you will not accept any feature. That's what we discussed. So when you talk about this multi-branch, so this multi-branch will accept only when you are having only a GBN. See that? Alright, so when I'm click on the GBN, it creates a multi-branch. So now in this, I'm going to define my harness. I'm going to define my harness with a slack of 4%. See, I'm going to define my slack of 4% and my diameter as 8. And if you change your cross section diameter, I think your cross section changes. And my bend radius is 20 mm. And you can set this one also 3 times or 4 times, whatever it could be. Right? So I'm going to route it from this bundle segment, right? Keep link with the selected object gets automatically linked, and I'm going to select to this particular branch. So now if you see, we have created a harness routing between these two components. See that the harness is generated, and if you see the diameter of this is 10 mm, and if you change it, it will change based on the slack value. Based on your slack value, your length is currently 623.36 mm. So this is your length. This is your length. You can see that 623.36 mm. So you reduce this well, you can see it has got reduced. So automatically apply that, your entire length also get reduced. See this. This is very much important for you to understand that in this case your length is also getting reduced to 606.24 mm. So I'm going to route it between, once again, between this component, that is this one, as well as this component with the specification as per this dimensions. So just give OK, and once you give OK, it measures the length based on that one. So just give OK. So now my harness is generated, and my harness is multi-branchable, that means branchable, and it has bundle segment. So you would like to edit this one, just click on this bundle segment and click on my branch definition, so that it takes me to the harness installation. Now as you can see, you are like currently in harness installation, and just give OK, you exit it, you are getting into harness assembly. So harness assembly and harness installations are both like your assembly design and part design capabilities. So from assembly design you can get into your part design capabilities, and from part design capabilities you can get into your assembly design capabilities also. So click on this one. When I click on this harness, it gets into your harness installation. Now you can see that you are under the harness installation, and your slack value is this one. Now when you get into this, see, I'm going to give, right, I'm going to give 1%, say for example 1, and apply it. This is my length. When I give 0, apply it, this is my length. Okay, and based on this value it is taking it. See, this is the value which is not allowing me. See this red line, that means for that slack value this is not taking it. Okay, so that you can increase the slack value. See, this is not accepting me because of this straight value. The slack is 0%, so I can give it 12 or something, right? And you can think about this radius also. I'm going to give 15. See that now it's taking. So most probably this, when you are having slack of 0%, this also contributes a lot in terms of your radius. So probably this slack value bend radius will be given to you while doing installation process, and it will be given as per the OEM standards. See, the minimum distance, now you can understand that, as I was telling you the point, the minimum distance between this battery connectors and this fan is almost 593.83, right? So that is the minimum distance. So just now when I move it to length, right, this is my length, that is 593.83 is the length. This is the length, right? So if I keep it, that the length between these two components, like the connector between this fan and this connector and that connector, to be 593. See that I'm just making 593, apply, it will take it. Okay, if it is 590, see that bundle dimension also takes it up, length is 590. So when you are selecting this length as a factor and apply it, and see that it has taken as this one. So now I just give OK. Now due to the factor, now what I do, I am going to move this battery. I'm going to move this battery or fan to the new location, because my bundle spec over here is how much? Is 590 as a length as a factor, right? So I'm going to move this slack to a new position. See this, sorry. I'm going to activate this one and move this battery alone to the new location. See this, I'm just moving it. But I have mentioned the length is minimum is 590, right? So now when I update it, see the length of mode is not meeting the requirement. So that means this is a problem which you will encounter. Routing in length mode, no solution found. That means just click on this one, go to this routing. The minimum distance, see this, it's bigger, the recomputed with bigger value. So it's a challenge. So always remember that this could be the challenge when you use slack instead of length as a factor. So this could make a big impact on your design aspect. So in this case, better always give slack as a value. So now when you give slack, see automatically the length has changed, right? And your capability of your design also get changed. Your length determines and your for the new location, your battery, your length is also recomputed, right? So that could be the case. But when you keep length as a factor, and this is my standard length, see that this is my standard length, and now I'm going to make 1964. It takes it. It takes it. See this. Beyond that limit, it is not accepting. That means when you reduce it, it will take it. But this is the value which is required, minimum. So slack and length has some factors. Okay. See. So that means the minimum distance between these two components has to be maintained. So always I would recommend use slack for any capabilities of this design, right? So even the slack is 0, no problem. But now the slack is 0. So you would like to have, say for example, 2% applied, your slack remains good. Okay. This is one which you need to understand while designing it. Okay. Now once it is done, you can see that this harness, right? You can give the color specification of this harness by clicking on this root segment and click on my multi-branchable, because this is not a multi-branchable. go to my bundle segment definition and select your reference as this yellow color, right? So I just given this yellow color as my reference, and see the root definition currently. The root definition for you currently is from this harness connector to the harness connector. So this is what we talk about contextually designed and contextually linked this surface, and where you have bundle connection point, and similarly you are also having a bundle connection point. So that is one clear. So now my challenge is that I would like to break, right? I would like to break this bundle. I would like to break this bundle in middle way somewhere and route one more cable, right? Now what I'm going to do is that I'm going to do something called multi-branchable. So I'm going to do branchable. Only one bundle segment of yellow color you can see, right? I'm going to branch it out. I'm going to do a branch. What do you mean by branch? I'm going to divide the entire bundle into one particular point. Say for example this one, in this particular point. I'm going to break it, and from here I'm going to make one more routing here, right? So one more routing I'm going to do this way, something like that. That's my objective. So when I do this, it's important for me to understand that what level I have to break it. Number one, what should be my diameter, and what could be my specification based on that one. And when you break it, you will have a question, do I need to convert that into electrification? Not required, because when you add a branch point, that point itself is electrified as one more junction sort of inputs. So there is no requirement for you to convert that point into electrification. Say for example, the same command you can see over here also. There is no much difference between this. See this, you have here add branch point, which is out of your scope of the feature, and the same you can find over here, and this two are the same, right? So that means this is within the multi-branchable command itself. You will have multi-branch point, and if you're done outside also you can have this branch points. So I'm going to click on my multi-branchable. You can see this is only one bundle segment. When I click on this one, it takes me to this particular bundle, and where I can select this bundle, and you know how to create a point on that one. So I'll keep as 0.50% and preview it and give OK. So now when I give OK, you can see that my bundle segment, now segment 2 appears, right? And exactly with this particular 0.1 and 0.3. So you can reframe the selection. So you can just select this one, reframe it, this is your component, and you can select this one and reframe it, this is your component. So this could be one particular harness which could play a role. So what I'm going to do now, I'm going to reduce this bundle. So which bundle? I'm going to reduce the diameter of this bundle. So go here and select your diameter. So this is my bundle and this is your bundle. So I'm going to reduce the diameter to this one. So I'm going to reduce it. So I'm going to reduce to 6 mm, for example. Apply it. So now if you see, based on the diameter or capability, whatever it is, I'm going to change it to 8 mm. So this bundle diameter is coming because of this slack value, and you can just apply it and give it OK. So now if you see that I've just broken the entire bundle to this values. So go to this, take this bundle segment and give a slack of 4% or something like that. Right? You can see that. Now when I give a slack of 4%, this bundle of diameter, you can see, go to bundle definitions, you can see all these bundles. One is 12 mm, see this is 12 mm and this is 8 mm. So 8 mm I will give another color for your easy understanding. So now apply. Now if you see my entire bundle segment, I just broken into two entities, right? And this is called branchable. This is called branchable. Yeah. Now I just broke down the entire harness, right, into two bundle segment and gave a slack value of all these factors. So one is having this diameter. So apply it, give OK, fine, you have it. Now what I'm going to do, I'm going to create one more bundle segment. See, I'm going to create OK and exit this one. So what I'm going to do, I'm going to create one more multi-bundle segment. Now what is this bundle segment is all about? I'm going to create the harness through this one, right? I can create through this one also, harness one. Okay. So what I'm going to do is that I'm going to click on my harness and click on multi-branchable, and I'm going to route on this. So now I will just teach you how to create your bundle segment. Okay, exit this one, and here you have your bundle segment. See, this is multi-branchable, this is bundle segment. So what I'm going to do, I'm going to click on my multi-bundle segment. So don't worry on that. I'm just going to select bundle. Okay. Okay, no problem. Just a minute. Okay. I'm going to use my bundle segment, and when I use this bundle segment, you can see that it will take as one part. And now I'm going to route the definition between this particular point. See this point? Yes, that point has taken, and this one. So I just given this one. So this is my separate bundle. So which at this particular point, I would like to ensure that my bundle is having tangency. This point is tangent with this reference surfaces. Yes, you can see that the bundle gets tangent with that. Now this is the difference between your multi-branchable and multi-branchable. So here I would like to give once again the radius as 8 mm. Apply it. Give OK, so that update it. Your radius becomes 8 mm. And now you would like to do some changes on this bundle. Just click on this bundle. You can see that the definition of this bundle is different, and you can set the color also for this multi-branchable also. This is my bundle segment, which I gave at the moment, yeah, specification of this component. So let me give one color for this one. Yeah, the major difference between your multi-branchable and bundle segment is this one. So if you see this component, this harness is called multi-branchable. That means it is branchable. When you branchable, you can see this two bundle segment. One we saw with a green color and one with yellow. This is one multi-branchable, this is one bundle segment. So this is called this particular component, right? When we talk about bundle segment means it is just a single entity. That means it is just a single part and having just only one bundle. You can't have more than, you can't split this bundle itself, right? See that. When I would like to split, exit this, and I would like to split. See, I would like to split. See, this is my split where you have branch point. So this is my branch point. It will not allow me to branch point for this bundle segment. Whereas I can use bundle segment to split over here. This I can split it once again. But all you would like to do the multi-branchable for this bundle segment, I can do it still once again. So I would like to create a new multi-branchable point. You can do that one. Okay. So that means multi-branch. Okay. So in this case, you like to have routing. I can use routing definition. I can use this point also. Once again, see this. The same point I'm using, right? I can start building my harnesses. So that's not a big challenge. So from here, what we learned is that we learned how to use multi-branchable, and we know what is bundle segment and what is difference between a multi-branchable and a bundle segment, and we know how to add a branch point and how to remove a bundle. So this is adding a branch point. Remove branch point is something this one. Simple. You can able to remove those branch points. So it becomes as a single cable itself. So that is the one which we can able to understand between your multi-branchable and bundle segment. Okay. So now I'll just give you some insight. I'm going to teach you over here how to use adaptive support and how this adaptive support will be useful in terms of creating your bundle segments. So your bundle has to change as per the diameter of it. Your support, in this case your support diameter has to change with reference to bundle diameter. That means what I'm going to do, just to show you what exactly the outcome, I'll open a file, new product. Okay, and I'm going to insert these two existing components. So I'm going to insert Windows vertical, and I'm going to just copy this and paste it over here. I'm going to paste it over here. Right, this is one. So, or I'll just I just made it this one bundle, right? Similarly, I'll just make copy and I'll make one more. So I have two adaptive clamps. So this clamp I'm going to move over here. See this mode, I moved it, right? So now, as we all know, to do any harness, the first step is you need to have GBN. I'm going to convert this as a GBN. Fine. So your GBN is ready. Now I'm going to use multi-branch board, and I'm going to use a root definition. The diameter I will just mention here as 6 mm diameter. Now route it between this clamp here and see this and this clamp. So what is happening here? Your clamp is getting changed as per the diameter. That is my end objective. Now due to this, I change this to 12 mm. Now what should your clamp also should change automatically to that, the distance, whatever it could be. See, this also should change automatically. So that is my objective. So in this case, what I'll do, exit this, and I'm going to route it between this bundle, yeah, and I'm going to use this bundle also. See that it's getting changed based on the bundle diameter. So each and every time when you give OK, you got it changed. Right now, if you change to 5 mm, see that bundle diameter also gets changed accordingly. So that means what is happening? Our products are getting updated, and your clamp is getting adaptive. That's the formation of this adaptive support. Okay. So in this case, I would like to go to bundle segment and change the diameter to 15 mm. You're getting adaptive support. And if you see, there is a formulas and relationship which plays an important role in this design aspects. What is meant by formulas and relationship? See that, right? You got it. The same way we need to adapt it. Okay. So the first thing what we need to understand from this clamp support, what we are going to use it. See that this is my clamp support which I would like to design now and do some changes. The first thing, you need to have a syntax. There is a syntax for this one. There is a syntax for this one, that you need to have a parameter like ELEC support hyphen radius is the syntax. Radius. So this is the default syntax which you need to have it for any of the design support. That means this is a user defined parameter. You need to understand this is something called a user defined parameter. User defined parameter. So this user defined parameter I'm going to define now in this case. The first thing, as we discussed during our initial class itself, I'm going to create a parameter called the same thing. This is a syntax you need to forget. Okay, ELEC hyphen support radius. Okay, this is my syntax, and I'm going to give the dimension as, say for example, 12 mm, and apply it and give OK. You can see that your specification comes over there. This is my syntax. I'm ready with my syntax. Now what is my objective? My objective is that I would like to make my formula to be equivalent to that. So what I'll do, I'll just click on this formula f of x, and you know that there is a relationship this is my radius. You can see this is my radius, right? 217, you can see here. This is my radius, right? So what I'm going to do, first thing, I'll convert this instead of radius into diameter first. So I'll convert this into diameter, apply this, same, there is nothing difference between this radius and diameter. I just converted that one because I'm defining the same thing in my bundle diameter also. That's the reason I'm making this one also in terms of this. Now what I'm going to do, see this, I'm going to make this radius, right? This radius, add formula. I'm going to make that radius, add formula is equivalent to this one. Just give OK. You get your bundle radius applied. Give OK, you get it. See that it got changed. So this is my radius, which I'm going to make it to, for example, 6 mm or something. Get it, right? So that means I just made it. And you know that you need to get published. So I'll just get to mechanical part design, and I will ensure that get into my tools, publications, and publish this electrical support alone. I'm just publishing this one. Just give OK. I'm just giving OK. So this could be the one adaptive support which I've created. So these are the formulas and relationship which I just made it now. And see this, in this case, my adaptive clamp for other one. See this one, see the formulas and relationship. This one, see that they have given so many formulas. You can, I will share you this one. You can also use it for reference. Always this is one syntax which you need to manage, right? The same way we are going to work on this also. So go to Windows, get into my adaptive support, and start using this one. Now this bundle list, this support is ready for my usage. So I'll just get into my product. Alright, and I will introduce this harness also. I'll just delete this, all this one. So I'm going to bring those adaptive supports. So I'm going to just have to save it. Anyhow, we'll save it, and I can save this into catalog, right? I can save this into catalog. So file, save as first. So I'm going to save as in our folder. In my data practice, in this location as adaptive support, right? 1. And I'm going to store this component into my catalog also. So go to content, online. I'm going to use my A3 batch, and I'm going to store this in the catalog also. This is my catalog, right? So I'm just using this catalog part. So go there, get into this component, right? Equipment, electrical assembly design, right? Electrical assembly design, and I'm going to store this component inside this one. So I'm going to into electrical part design, because it's a part. I'm going to store it, this component, inside my new folder, A3. And this is my catalog, and I'm going to store this one in my support. This I have supported, and this support I can start using for my installation process. So this is one way where I would recommend you to use your harness installation and start placing your components. So let me show you an example. Now in this case, Windows vertical, what I do, the same product, I can instant in it. I just instant in it. I just move this one and place it over here, and copy this and paste it. Probably I felt this component is wrong, but anyhow, I'll just see that if it is wrong, we'll try to fix that one. just move this one. So now the dimension could be a challenge. I'm just seeing that, anticipating that, no problem. I'm getting into electrical harness assembly, and I'm going to use something called geometrical bundle for this one and route it between. So I'm just going to make it as 12 mm, route it between this bundle. Yes, see that it's getting changed, adapted. So this one, see that it is getting adapted as per the dimensions. Apply it, just give OK. You can see that the dimension is getting adapted. Now if you change this one, see your support is also getting changed. See this, you're changing this one, apply this one, and your support also gets changed automatically. Yeah, see that it is also getting changed. Probably the position of this is not correct. Okay, so this means your adaptive support also gets adapted according to my harness positioning. So this is one way where we will be keen in making the harness adapt as per the requirement. Okay, so now I would like to place this in my component. This is in, I'm placing in harness in a space. Are you guys with me, please? In this exercise, what I'm going to do is that I'm going to place my component, the harnesses, whatever we have created, right? The support, adaptive support, whatever we have created in this surface. So just make a note that when you want to place your harness, right, on any of the surfaces, you have to use electrical assembly design. That means I'm going to use placing of components. So I'm going to use smart placement. I'm going to use smart place to place those components. So now I'm currently in electrical harness assembly. So what I'll do, I'll just go back to my equipment, electrical assembly design. So this is beauty of CATIA V5 electrical harness, where we are having something called smart placement. So I'm going to use this location, the location which we have created just now, right? This is my data, something with 3, and this is my data practice, and in that you have this catalog, right? I'm going to use the same catalog. So where I'm going to use smart placement, this is my smart placement, and where I'm going to call the existing connector inside this and place it over the surfaces. So this is called smart placement. Okay, and I'm going to locate my folder, and this is my location of folder, and this is my catalog which I stored just now, right? In that support I have made adaptive support, right? Just see this adaptive support. I'm going to take this adaptive support, see that can just keep it on my surface. See, this is my surface, right? I'm going to keep like this on that one. So your adaptive support is placed one over here, right? And I'm going to place one more like this and rotate like this. See, I just placed one more, and I'm going to place one more like this and start rotating like this. So this is, you just place your harness supports wherever you would like to do it. So just place that. Okay, and now what we did, we just placed all your harnesses in this particular support, and I would like to use, see this positioning also. See how it is positioned. So that's the beauty of the smart placement, where you can define it and ensure that it goes and sits exactly there. So that is the purpose of smart placement. Wherever you would like to place it, you just place it and orient it very important is orientation has to be set right. So now from here I'm going to start using my routing, right? I'm going to start routing process. In this routing process, so this smart placement, which workbench we used, don't forget that we are using electrical assembly design. Anything which you are going to place on space or equipment or connectors or whatever it is, you're going to place it on the components like this. So this is how your equipments will play, and this is called a smart placement. So don't even forget this smart placement as an important factor. And this, yeah. So what I did, I'll just delete this, all these three supports first, no problem. Delete this. I'm going to use smart placement. Select the location. You know where the catalog has stored it. You got that idea, right? And click on this one. Automatically, you can see this compass will come. Once you click this, automatically it will show you, guide you where you can place it. Now, see, this is the freedom you have it. I will tell you how to place this component with the coordinate system, all the stuff, but you place it over here. And this is first which I have placed it. And you can just rotate that one. How the orientation you would like to have, something like that. You can rotate it. Later also you can rotate it. And you see this compass position also you can take it up. And I'm going to use this one and keep the second support there. And I'm going to place my third support over here and rotate it as per the orientation. So wherever you would like to place it, and rotate it like that, and just give OK. So sometimes you feel that that's not correct, just click on this one, snap on, click on this one and rotate like this, whatever the position is, right? And you want to know the coordinate system, right click, edit it, you can know the coordinate system also, where to proceed. Okay, this is also possible. With absolute access system, you can able to locate the position also. Then this is the freedom you will have it. Say for example, when you do harness installation, they will tell you, you just maintain minimum 300 mm between one harness support to another harness to hold it rigidly under drastic conditions. So that could be the case which you can do it. Okay, clear? Yeah. So now, placing of any components is electrical harness assembly. I'm sure you will forget after 10 days. Remember this one. Anything I would like to place it, I will use electrical assembly design. Down the line, I will tell you how to place using manage links, advanced level of linking, where no need to place it. It automatically you can create an XML code or something like that, where it can come and place your equipments as per the process. Okay, that is possible. Now, in this case, what I'm going to do is that I'm going back to my electrical harness assembly because I'm going to start routing it. So harness routing. So where I need to have defined geometry. Yeah, already there is a geometry one segment. And I'm going to click on my active GBN is there. See that? Even this part is active, right? My part is active. If I click it, you will get a message that there is GBN is not active. So always ensure that you are having a GBN, and this GBN is flexible assembly. You know what is flexible sub-assembly, and I'm going to use my multi-branch pull. So it's not active, so activate this multi-branch pull of this GBN for me. So now you just click on my multi-branch pull and start routing this harness. So this harness with this dimension, just take it. It's taking this point and this point and this point. Now the harness what we gave is adaptive support and it is taking it. This is because the reason I have given this slack as more, so apply it, you can just give it. And as rightly pointed out by I think Devananda or something, who you want to give a local slack, you can give a you can give a local slack in between, right? You can do that down the line. But as of now, I'll just apply it straight. Let it can be like this also at the moment, the harness, right? Right. My formulas, what I have given is not correct, but that's the way you can adapt the harness as per the requirements. So that means your smart placement plays an important role in placing your component and doing your harnesses. Down the line, if at all you would like to change the position now. See, I'm going to change the position of this harness, this support, something, sorry, and this support alone, and just moving a bit. So automatically your harness also get changed accordingly. Yeah, please. Uh-huh. Three support. Okay. I'm getting into the data. And I'm going to use the same data, and I'm going to use support. So same thing, I want to place this. So which workbench will go? I will activate this one, go to my electrical assembly design, and I will get into my smart placement, and I'm going to place, I'm going to use smart component. I'm going to use this one. This is my copied path catalog. Open it, and you will have this catalog. So this, in that I will have one more support. This is my support. So this is my support. I'm going to use it. See this? I'm going to use my support over here. This is my first support. You can turn this way, whatever the orientation is. This is my first support, and this is my second support. So this is my first support and second support. And I can have one more support over here. Right? So how many supports you would like to have, you can add it. No problem. I'm going to add a number of supports. So this is something like which I added. Right? So what we have defined is that I just placed my harnesses support, and I would like to route through this one, right? So this is under my geometrical bundle. So now get into my equipment, electrical harness assembly, and get into my routing. My geometrical bundle segment is active, and I'm going to give 1 mm, and I'm going to give my diameter as 6 and route it. So slack is, in this case for me, it's this one. So I'm going to select, this is my first support. Yep. This is my first support. This is my second support, and this is my third support. So all this harnesses is going through my first support and second support for a slack value of this much. This is my support which is sticking. Right. So what's happening now is that all the supports are getting through the same bundles. So if you see this, I'm going to give this one as yellow. Apply it. Right. Fine. Okay. Now I'm going to click one more harness, multi-branchable. I'm going to create one more multi-branchable. See, as a branchable, I'm going to use the same multi-branchable, and I'm going to use route it, and I'm going to use the same harness. Say yes here, and I'm going to use the second one, harness here, and I'm going to use the third one, and I'm going to use the fourth harness support also. So in this case, what I'm doing, I'm just using all the places the same harness, and if you see, your bundle will lie in line with that. Both the bundles will be lying in that. So this is also 6 mm. Go to route definition, and I'll give this one as some other color. Say for example blue color. Apply it, give OK. but practically speaking, now both the harnesses are going through center, because my definition of harness through the center has been defined very clearly. Both these harnesses are going through the center. See this, bundle segment 1 and bundle segment 2, both are going through the same, because both the cables I would like to go from first support, second support, and after this fourth support, one bundle will go other direction, the other bundle will go other direction. Possibility, practical application. Now what I'm going to do is that I'm going to teach you how to arrange your bundles within your harness system. Right? I'm going to arrange your bundles. So I routed it, but I would like to ensure that positioning of harness is going to play a role. So in this case, I'm going to click on my component. This is my component. This is my first support. Just see that. I'm going to click on my first support, and once I select the first support, you can see that there are two geometrical bundle segments. One with blue color, see that, one with yellow color, right? This is my yellow one, and this is my blue one. You can see this, right? That means I'm just moving these two bundles within the support. I would like to move on the top or something like that. I'm arranging the bundles inside the support, so there is no interference or clash. When I do this, what happens to the next one? What happens to the next one? So what I'm doing, I'm just moving these two geometrical bundles, in this case, right? In this case, these two geometrical bundles inside the support in the direction. You can use that parameters, or you can just directly select it and move it. You can see the values getting changed. At the same time, this bundle is getting connected to support 3, support 4, support 5. See that, support 2, so all the things, right? That means what I'm going to do, I'm going to select and ensure that propagate on. So when I select propagate on for all the components, you can see your harness are getting propagated. When I select it, propagated, all the location it is propagated. So here also it's getting propagated. That means it's something like tangency propagation, what you create in surface capabilities, the same way you're going to do it. But still I'm not convinced over here, there could be some interference over that particular point. So what you can do now, apply it, give OK. So I'm going to use arrange bundles. Instead of selecting first support, I'm going to select the second support. And now you know that how to move on this compass. I'm going to keep my yellow there itself, and I'm going to select my blue one and move the other direction, something like that, right? And I will ensure my propagation in the first, already I've done, right? Why to do this? So I will make this off. I'm going to make it off, right? And propagate, so that your second position also I'm just propagating it. See this, the bundle location. So that means you can able to control your propagation at each and every location and support, and ensure that there is no interference happening between the harnesses. So I'm just going there, and I'm going to arrange your support in this particular support, where I'm going to manage my interference. There is no interference happening here. It's okay, fine. Here also it's fine, no problem. There is no interference happening here. So there is no clash happening between these components. You can see this, there is no clash. Probably it could happen here. So there could be a clash between this, but there is no much interference happening here. So this is also very much important while designing aspects. Arrange bundle means I'm going to arrange your bundles inside your support. It could be one bundle, two bundle, and from there the bundle can go to the next level. And within the bundle also you can vary the slack. One bundle can have a maximum slack, the other bundle can have a less slack. Possibilities are there, right? So you can control this way and control the arrange bundle so that there is no interference or clash happening between the components. Okay.